All right, hey Cassandra, let's see if I can try this with my mouse. I still can't find my bamboo tablet. I think it might be in my classroom. So I'm going to try to draw with the mouse, so bear with me here. So to find the value of cosine of the angle theta, which is the angle, in this case, even though it's the larger angle on the outside, it's going to have the same value as the angle inside, our kind of our reference angle here, or the angle closest to the x-axis. So the first thing we're going to do when you're given a point on the terminal side is we're going to create a right triangle by dropping our perpendicular from that point to the x-axis. So wherever it is, go straight up or straight down to the x-axis. We're going to form this right triangle where one of the sides will always be on the x-axis. Okay. Please don't go horizontal. Don't do it with the y-axis. That won't work. So in this right triangle, the angle closest to the x, or to the origin I should say, is angle theta. And we're trying to find the cosine of this angle. So we do know a couple things about this right triangle we formed. So we know that, for instance, because this is 0, 0, we've gone 6 units to the right, since our x-coordinate is 6, and we've gone up the square root of 13. Okay, now if this was in another quadrant, like say we're in the second or third quadrant, x would be negative. And if you're in the bottom ones, the y-coordinate could be negative there as well. So you might put negative square root of 13. Now that doesn't seem correct for a right triangle, but it does matter when we talk about the trig value. So what we're going to do is we need to find the cosine of this. And since we formed a right triangle, we can use right triangle trig. So we're thinking back to so, ka, toa. So ka, of course, is the adjacent over the hypotenuse. So for my angle here, here's our adjacent. There's the 6. But we need our hypotenuse, which we don't know yet. So to find this length, obviously we have a right triangle where we know 2 out of 3 sides. We're just going to use a little Pythagorean theorem, and since my writing's pretty bad, we'll try the calculator here. So we know that a squared, well, okay, that didn't make things any better, a squared plus b squared, and even though it's negative, it doesn't matter if I put it in as a negative, because when we square it, it's going to come back out positive anyway, should equal c squared. So there's my hypotenuse squared, and of course if we do the square root of 49, it tells me my hypotenuse has a length of exactly 7. Okay, so we know our hypotenuse is 7. So we're trying to find the cosine value of this angle, which is the same as this angle, and that is the adjacent, which is 6, over the hypotenuse, 7. So the cosine of our angle is 6/7. If we needed to find the measurement of that angle, of course we could do the inverse cosine in our calculator. So you do trig, inverse cosine. This is not part of the problem you needed to do here, but just to expand on this a little bit. My calculator is in degree mode, so it's going to give me my answer back in degrees. So we know that this smaller angle is 31 degrees. And if we really wanted to know how many degrees this angle was, we could subtract that from, of course, the full circle of 360. So 360 minus our answer, and it will tell me that that larger angle is really 329 degrees, basically. Anyway, hope that helped.